How could we find out? What's your instinct? Even if it's just looking at these parts. What could we do here? Why don't we try multiplying it out? This is a distributing problem or a box problem, depending on how you multiply. If we have x times y plus 2y plus 2x plus 4. We want to know when that equals xy plus 4. You guys have more space than I do. Does that help a little? Because what can we do? I'm going to scooch this to the side so I can write it over here again. So what we have is xy plus 2x plus 2y plus 4. And we want to know when that equals xy plus 4. It's the same thing. I'm just giving myself some actual space over here. What could we do here if I just gave you this part? Say it louder. I can't quite add the 2x and the 2y. Good instinct, though. Because they're different variables, so we can't combine them together. But I agree, we're going to need to use some algebra stuff. They're already positive, so what are we going to do with the 4? Subtract 4. Ooh, chunky pen. Holy cow. Let me try that again. So what if I subtract 4 from this side? Minus 4 from that side. That guy cancels, and that guy cancels. I like that. We like things canceling. That makes our lives easier. So now I have xy plus 2x plus 2y equals xy. Okay, that xy guy is kind of gross. What can I do to get the xy away from over here? This one. Super close. It's already being added, so what do we need to do? Subtract it. Let me subtract xy from this side, because I'd really like him to leave. He's kind of gross. Minus xy. I want to get it with this one over here. When I do that, that guy cancels out. And ooh, that one cancels out. So we're left with, when does 2x plus 2y equal 0? Because there's nothing left on that side. Could we come up with some values then? See if we can get y equals. What can I do to get y equals? Let's try subtracting the 2x. Now I have that 2y equals minus 2x. Can we get y by itself? No? Ooh, what if we get rid of all the gross stuff up top? Can I get y by itself? How? Divide by 2. Zoom back out so we can see. Divide by 2. Y equals negative 1x. So if y equals the opposite of x, maybe x is 3, what would y equal? Negative 3. If x is 3 and y is negative 3, wouldn't that work? Because they cancel out. If x is 2, y is negative 2. If we have equal opposite things, they're going to wind up canceling out sometimes. But does it work for every value of x and every value of y? Or just specific ones? Just specific ones, right? Little ones. So this is something we call a sometimes true. This is sometimes true because it only works when y equals the opposite of x, or when x equals the opposite of y. If it works every time, if it is always true, it'll be something that works no matter what x is. It'll always work. Always means always. Like 2 always equals 2. 3 always equals 3. Something that never works would be when we get something like 0 equals 7. 27 equals 2. Those don't work. Those are not true. If we get an x equals or a y equals, it's sometimes. It only works when that piece is true. So what we're going to be doing in this activity today is we're going to be practicing identifying when we have sometimes, meaning I could solve it and get a solution. When we have always, which means it don't matter what x and y is, these things mean the same dang thing. Or when it's never true, when these are two entirely separate pieces that never touch. And the reason we care is because of something called an identity. Identities are one of those things we use in math all the dang time. We just don't ever really put words to it. An identity is an equation or an expression that is always true. We usually use equations like x is the same thing as 1x. X plus 0 is the same thing as x. I can add 0 to anything. It's an additive identity. So those things that help us solve math, 2 plus 3 is the same thing as 3 plus 2. The fact that I can change them around. Those are identities. We don't use the word identity all that many times because it makes things overcomplicated sometimes to talk about what is the identity here.
I just changed the toner.
Okay.
I said that's all that was wrong. So if you see another problem tomorrow, I can call.
I'll let you know.
If you can't fix it.
Thank you.
I did the toner without you.
Ooh. Okay. So what we're going to be doing is in your book, it has, I think it has the thing. I think I put the thing in it. Is there a big old table like 2 pages later? Or did I cut the table because it's useless? I genuinely cannot remember. Let me check. Page 40. Oh, good. I finally saved us the paper because it's a page that doesn't make any dang sense. Yay. Never mind. So what you're going to do is working in your partner, which I will put the partner page back up in just a second. What you're going to do is you're going to take a deck of cards. Not a deck. There's like 14 cards here. And you're going to sort them into 3 piles. Sometimes true, never true, always true. You may need whiteboards, dry erase to do things. You may just start to notice patterns. You can do things like that. So you're sorting it into 3 groups. There's not more cards to add in this time. Like last time I kept adding more and more and more cards. It's just this one set. But we're going to have it today and we're going to work on it tomorrow. So when we get it into sometimes, always, and never, for the sometimeses, you're going to find the solutions. So I'll put the partner page back up. So these are our groups. So get into these groups. Get with your partner. And I will come and pass around cards. And first things first, I want you to count and make sure there's 14. Because I have like 3 floating individual cards. Okay, so I know we have some of our groups kind of floating around. Here's nothing here. Something on. Why don't you guys over there instead of being a group of 3? You guys work together right there. Because Claudia's not in here. So you 2. In the back. With the hoodie. Headphones. Okay. So, also the one that has non-paper clips. So each group is 1 set. because I have several floating individual cards, and I think there's more than 14 of them in there. So, if you have more than 14, make sure they number 1 through 14. Huh? You only have 8? Okay, well then we're just gonna go ahead and rebundle that. And we're gonna try a different set, and I'll put those in my, let's figure this out. This one figure this out. Because like, these are all my loose cards that were in the box. Because my kids last year did not. Alright. Yeah, right up here. Yes, this is Noah. Yeah, I started writing it and I'm like, oh, I have 2 Noahs now. Thank you, sir. All right, so it's gonna go with my loose packs. Make sure you guys have 14 cards. All right, so sort them out. You guys are working on this and we have lots of time. If you need dry erase, I've got dry erase markers for behind Surgeon Cat. Boards are in the box. You can use whatever you want. Or you can use scratch paper. You got space on that page too, okay? Sorting them into sometimes, always, and never.